Welcome back to the Physics 141 demonstration series. Today we are going to show that sound waves transport energy. To make this demonstration, we are going to use the acoustic energy from the vibrating tuning fork to drive the motion of this ping pong ball attached to the end of this pendulum. So when the tuning fork is struck, mechanical energy is transformed into sound energy. Now, this process follows a very precise cycle of energy transfer and wave propagation. So before we do the actual experiment, let's first be sure and convince ourselves that we understand the steps of this cycle. So striking the tuning fork again provides the initial mechanical energy. And so the palms of the tuning fork, as illustrated in this simulation, vibrates very rapidly, pushing away the surrounding air molecules. And these repeated patterns on the vibration creates areas that has high density air molecules and areas with low density air molecules. So the areas of high density air molecule are known as compression zones, and the areas of low density air molecules are called rarefactions. And we can see that the compressions and rarefaction zones propagate in the same direction of the vibration of the particles. Now, we have here several of these tuning forks. We have this one, for instance, that has a characteristic frequency of 512 Hz. So when I strike this tuning fork, we hear a very particular chip. And this chip will be different from this one that is at 384 Hz. So you can see that the chip is different. And it's different from this one too. This one is 128 Hz. So when we strike the tuning fork is vibrating. However, when we look at the tuning fork, it looks like it's standing still. The reason is that the vibration is so fast that our eye cannot resolve it. But let's see that we are actually having some vibrations here. So in order to do that, I'm going to strike the tuning fork and put it close to the ping pong ball. And we can see that there is a transfer of energy from the vibrating tuning fork into the ping pong ball that acquires kinetic energy and starts oscillating. So it is the vibration of the tuning fork what makes this ping pong flinch. However, sound is actually these vibrations. We cannot have sound without vibration. It is the same energy that produce the vibration on the tuning fork to excite the ping pong ball and make it oscillate. That the same energy, as I was saying, is the one that also pushes the molecules of air away, and by doing that is creating a pressure wave which produces the sound. And this is all, folks.